Good morning, students. In the previous video session, we have discussed about the linear momentum, angular momentum, and the torque. And today we are going to a new topic, that is types of equilibrium state. You know what is meant by equilibrium? First, you have to know the meaning of the word equilibrium. Assume that you are sitting with your friends on a seesaw. We have the practice that sitting in seesaw and playing while our childhood. So when you are sitting in this seesaw, sometimes you know that you and your friends are sitting both sides of this seesaw. You can see that it will be in a stable state. It will be in a same state. Either this side is not lifting, that side is also not lifting. Both sides of the seesaw, while you and your friend sitting, both sides on the seesaw is balancing. Sometimes you can see that. That is what we are saying, equilibrium state. What state? Equilibrium state we can say. So, here there are some types of equilibrium given. You can see in the page number 228, there is a table 5.2. This is one of the important 5-mark question in this unit. So, there are some types of equilibrium. Translational equilibrium, rotational equilibrium, static equilibrium, dynamic equilibrium, stable equilibrium, unstable equilibrium, and neutral equilibrium. So, during translational equilibrium, what will happen? Let us see. Assume that there is an object like this. Here, one force is acting this side and another force is acting this side. This is 10 Newton force and this is also 10 Newton force. Assume that there is an object which is kept on a horizontal surface. An object which is placed on a horizontal surface. You are applying a force, you are pulling a force with 10 Newton this direction and your friend is pulling the same object from other direction. Both are applying the same force 10 Newton and 10 Newton. So when you and your friend is applying 10 Newton force on this each side of this object, what will happen now? What will happen now? The object will not move this side or either this side. It will be in a state, that state what we are saying translational equilibrium state, and during this time what will happen to this force? Force, what is happening? This side 10 Newton force, that side also 10 Newton force, so opposite direction equal force is acting. So what will happen means this force will get cancelled. So this direction will come minus 10, that direction plus 10. So what will get means you will get the total force 0. Because the force which is acting in opposite direction and the size, the magnitude of the force is same. So the direction 10, this direction 10. When we are saying, when we are taking the net force, you will get a 0. That is what the first one, translational equilibrium. Linear momentum is constant. Here the linear momentum, the motion in this direction and this direction is what? Constant only. Okay, so the force, the net force also what we will get? 0 net force. That is what the first one. 2 point only, translational equilibrium means what? Linear momentum is constant and the net force acting on this is 0. Understand? You see, this direction 10 Newton force, that direction also 10 Newton force is acting on an object. So both the direction it is acting, so the net force is getting 0. If you are seeing the linear momentum, the movement of this is what? It will be constant. That is what the first one, translational equilibrium. Next one is rotational equilibrium. And here what you can see means, assume that on rod, on uniform rod, which is kept on a pivot, okay? Which is kept on a pivot. Here there is a 10 Newton force. 10 Newton force. Here also assume that there is a 10 Newton force. Or you can tell that this direction 10 Newton force. 10 Newton force. Now this distance is some 10 centimeter or 10 meter. This distance is 10 meter. So what you will get the torque? So you know this torque formula, torque is equal to F into D, so 10 into 10, so you will get 100 Newton meter, this side torque, 100 Newton meter, this side also what you will get the torque, you will get 100 Newton meter. So this state, during this state, you know this thing, the force is acting opposite direction, this direction, so it will rotate in this direction, anti-clockwise direction, and this side also will rotate anti-clockwise direction. So this side also 100 Newton meter, that side also 100 Newton meter means here it is a rotational thing. So you can tell that the angular momentum is constant. Angular momentum is constant. So what will happen to this torque, net torque? You see? The torque, this side 100 Newton meter, that side also 100 Newton meter, which is acting on opposite direction. So minus 100 plus 100, again net torque is what? 0 we will get. Understand? This is what? Rotational equilibrium. So understand this concept. You see, assume that a uniform rod which is pivoted on an object pivoted from its center, and both sides there is a force acting. Here 10 Newton force which is acting downward, and there 10 Newton force which is acting upward. Assume that, and both the forces acting at both ends at a distance 10 meter means, so what you will get the torque, this side torque formula is F into D. So when we are calculating 10 into 10, what we will get? 100 Newton meter. This side also you will get 100 Newton meter. Now if you are taking the net torque, you will get what? 0. So this is what we are saying. This state is rotational equilibrium. During this time, angular momentum is constant, and what? Net torque is also 0. Next one is static equilibrium. Next one is static equilibrium. For this static equilibrium, you can take the same example, seesaw example. Assume that seesaw example, both side person sitting. While sitting, both side one state is there, no? Either this side is not lifting, this side also not lifting means both are balancing and sitting there, then we can tell that state is static equilibrium. What state? Static equilibrium. So during this static equilibrium, linear momentum and angular momentum is constant. There, this moment also, what you can tell? Constant you can tell. So during this time, net force and net torque also 0. There, the force, both sides acting, the force on the seesaw is what? The net force is 0, net torque also 0. You can find out the net force like this and the net torque by using the formula torque is equal to F into D. So linear momentum and angular momentum is constant. Net force and net torque is 0. That is what a static equilibrium. Dynamic equilibrium also same state. For I'll tell one best example for dynamic equilibrium. Assume that you are digging. You are digging and taking the sand, and you want to make water, a big dish. So while you are digging this ground, you are taking the sand outside. You think that your friend is sitting there, and whatever the soil you are taking out, all the soil which is keeping inside again by your friend. So whatever the sand you are taking outside, again it is filling. Again it is filled by your friend. So the state, there will be a state, no? What is that state we can tell? Dynamic equilibrium. So that equilibrium state we can tell dynamic equilibrium. Keep this example on your mind, and during this time linear momentum and angular momentum is both is what? We will get a constant. Also this net force and net torque also 0. So now I told about the 4 types of equilibrium: translational equilibrium, rotational equilibrium, static equilibrium, and dynamic equilibrium. Translational equilibrium means what? Translational equilibrium. During translational equilibrium, linear momentum is constant, net force is 0. Now rotational equilibrium, angular momentum. Rotation means angular. So rotational equilibrium, angular momentum is constant, and net torque is 0. And static equilibrium, what are linear momentum and angular momentum both are constant. Net force and net torque acting on the object is what are 0. Dynamic equilibrium also, linear momentum and angular momentum is constant. Net force and net torque is 0. This is what about 4 types of equilibrium. Now another one is what are stable equilibrium. For example, you can take a cone, okay, a cone. Assume that a cone which is kept at this position. The cone is kept at this position. You know that the center of mass is acting here. Center of mass. Now, center of mass is acting here. One cone is kept in this position. So this is what we can tell stable equilibrium. I will tell you how. Suppose this cone, the same cone, you are tilted slightly. Tilted means what? You displaced slightly. Just assume that one cone is like this. One cone is like this. You are just displacing. Displacing means just displacing like this. So you can see that the cone will go in this position, and again it will come back to its original position. This we can tell stable equilibrium. So if you tilt it slightly, what will happen? Again this cone will come back to its original position. Now what will happen to this center of mass? Center of mass slightly higher. Center of mass is slightly higher if you disturb from this original position. Now what will happen to this potential energy means, in this potential energy, in this state potential energy is lower than when it is lifted higher. So potential energy is increasing when it is slightly displaced, or potential energy is higher if it is disturbed. So that is what we are saying stable equilibrium. Understand the concept? Assume that one cone is like this. You know this cone. Easily you can place it by its base. When it is kept in this position, center of mass is here. So what will happen means, you are just tilting or displaced slightly. So what will happen? If you just touch and leave, it will come back to its original position. So again it will come back to its original position. So when it is slightly higher, in center of mass, what is happening? Center of mass also becomes higher position. So the potential energy also becomes higher. So this state we are saying what are stable equilibrium. Now unstable equilibrium means the same cone example you can take up. Assume that now you kept the cone in this position. Now you kept the cone in this position, you know, center of mass will be like this. So now what you are going to do is, now assume that you have just tilted this. What will happen? What will happen? This object will fall like this. This object will fall. Okay? This object will fall. If you tilt it slightly, if you touch slightly, what will happen? It will fall. So that is what we are saying, unstable equilibrium. Not stable, not stable, not. So that is what here, unstable equilibrium here given. So during stable equilibrium, linear momentum and angular momentum is what are? 0. And during this unstable equilibrium also, linear momentum, angular momentum are 0. But what will happen to this? What are? It will not come back to its original position if slightly disturbed. And the center of mass, what will happen? It shifts slightly lower. You see, here the center of mass. If you tilt it this much, it will get lower. So the center of mass is getting lower. Center of mass getting lower means what will happen to the potential energy? Potential energy, that is also decreasing. That is also decreasing. This is what unstable equilibrium. So here 3 point. Remember this 3 point: linear momentum, angular momentum. Stable equilibrium, unstable equilibrium, both are 0. In stable equilibrium, what are? If you disturb slightly from, what will happen? It will come back to its original position if you slightly disturb also. Center of mass is higher, potential energy higher. And unstable equilibrium, linear momentum, angular momentum are 0. If you slightly disturb, what will happen? It will not come back to its original position if you slightly disturb. So what will happen to this? Potential energy decreases and the center of mass is getting what are? Minimum. And the last one is what are? Neutral equilibrium. Neutral equilibrium, you can tell this same example. You see, assume that one cone is like this. Okay, one cone is in this position. Cone is this position. So center of mass is here. So assume that the cone is now in this position. This is what the neutral equilibrium. In this position, you are disturbing this. So what will happen? This direction you are disturbing, or this direction. So you can see that like a water bottle, it will roll over. So this state only we are saying neutral equilibrium. Center of mass is staying at the same position. So the potential energy remains what? Same even if you disturb. And what will happen to this linear momentum, angular momentum? Both are 0, and you slightly disturbed also. What is happening? It remains same in this equilibrium position. This is what you see. You are slightly disturbed, but still it is in the same position. You know that you can do this experiment now. Take a cone, ice cream cone or any cone you take. Keep this in this position, slightly disturbed. If it is coming back, it is what of? What state of? Stable equilibrium. Keep it in this position, slightly disturbed. It will not come back to its original position. So that is what unstable equilibrium. Now you keep the coin in this position and just touch it. You can see that it is rolled over. It's roll over. When it's roll over, what will happen? It stays on same equilibrium state. And all these stable equilibrium, unstable equilibrium and neutral equilibrium, all these three equilibrium, what will happen? What will happen to this center of mass? Center of mass stays same. Not same, stable equilibrium, center of mass raise higher, so potential energy also higher. In the unstable equilibrium, center of mass, what lower, so potential energy what is happening? Decreases. And the third one is potential energy stays same because the center of mass stays same position, because if you slightly disturb also it stays in the same equilibrium state. So this is what about the types of equilibrium. Dear students, it is one of the important questions. You can mark it page number 228. It is important 5-mark question. Keep these examples in your mind and study this. You will not forget. So again remember, translational means linear momentum constant. Then what? Force. That force is zero, rotational, linear momentum, angular momentum constant. Then what is happening? That force and then the torque is zero. Static and dynamic are same. Linear momentum, angular momentum constant. It's what? That force and that torque is zero. Stable equilibrium, unstable equilibrium, neutral equilibrium. First one is same. Linear momentum and angular momentum are zero. And keep this one example. Stable equilibrium, if you slightly disturb, it will come back to its original position. If you disturb also, center of mass is higher, potential energy higher. Unstable equilibrium, slightly disturbed, it will not come back to its original position, original state or original position, and its center of mass is getting what? Lowering down, so its potential energy decreases. Neutral equilibrium, what? It remains same equilibrium state, and center of mass also stays same, potential energy same. So this is what about the types of. Next one is about a new topic, which is we can say couple. What is it by couple? So couple force we can tell. You know this thing, assume that road, a uniform road like this, uniform road which is pivoted from its center, two forces which is acting opposite direction but equal force. Magnitude is equal and the center of mass is same, midpoint. Assume that consider a uniform road AB. Okay, you can keep this as AB. AB is a uniform thin rod and placed from its midpoint C, and the center of mass is at the same point C. Now both end two forces acting which is equal in magnitude and opposite direction. Opposite direction forces acting equal magnitude 10 Newton. Assume that 10 Newton force which is acting on this both end of this uniform rod, and this both rod, this force is what again? Opposite direction. So what will happen to these forces? The forces will get a cancellation. The forces are equal in size, equal in magnitude, so it will get a cancel each other because of which is these forces in opposite direction. Now what you can say is this is in its translational equilibrium. This is not in translational equilibrium. Let us see whether it is in rotational equilibrium or not. So that is what you can see that. So listen, on uniform node which is kept up, two forces which is acting at the both end and the center of mass is at the midpoint. These forces acting opposite direction, so both forces, the net force get cancel each other. So it is not in its translational equilibrium. Let us see whether it is in rotational equilibrium. It is not in rotational equilibrium. Why it is not in rotational equilibrium? Then we can see. You see, this force is acting this direction. Here the force at this end. The moment of force at the end A is acting this direction. But in this direction, anti-clockwise direction. The same thing, the moment of force acting at this point B, also in what anti-clockwise direction. So it is in what rotational equilibrium. We can say. So this is what we are saying. Couple. What we can say? Couple. There is a definition given in your textbook. A pair of forces which is acting equal in size, equal in magnitude, and acting in opposite direction, producing a turning effect. Its line of force not coincided. This is a line of force. Here, the line of force is not coincided, but the forces. These two forces cause a turning effect. A pair of forces cause a turning effect. That is what we are saying, couple. You can see steering, a best example. Car steering or any vehicle steering. One side this direction force we are applying and another side this direction. So our right hand also giving anti-clockwise direction, left hand also anti-clockwise direction. So it is in what rotational state. So we can say it is in a state of rotational equilibrium. So there is a turning effect which is given by these two forces, which is applied by this right hand and this left hand. A pair of force is applying on this steering to rotate this. That is what we are saying, couple. There is a definition which is given in the page number 230. You can learn this definition. A pair of force which are equal and in magnitude and in opposite in direction and separated by a perpendicular distance. Its lines of force not coincide, but it gives a turning effect called what? Couple. So this definition you can learn in page number 230. Definition is there. It is on 2 mark question. You can mark and learn. So again remember that on uniform node we kept from its midpoint the same distance, two forces acting at the end A and the end B. These two forces which is acting in the opposite direction but equal in size. A pair of forces acting equal in size but in opposite direction. These two getting cancel each other, so it is not in its translational equilibrium. Let us find whether it is in its rotational equilibrium or not. For that we can check, but here it is anti-clockwise direction. This force produce a turning effect in anti-clockwise direction and the moment of force at the point A also producing a turning effect which is in anti-clockwise direction. So we can tell that it is in its rotational equilibrium. That is what we are saying, couple, a pair of force which is equal in size but in opposite direction, acting perpendicular to the road, and what are the lines of force is not coinciding, and that cause the force which cause a turning effect called the what? Couple. Okay, so study this. Page number 230, couple definition, and page number 228, types of equilibrium. 5-mark question and this 2-mark question. Can learn it. See you all. Bye bye. Thank you.